Hello dear friends, come to the class of engineering mechanics. In previous classes I discussed about CO1 where we discuss about forces, different types of forces, their application, their effects, correct? Now in CO2 we will talk about trusses. What is truss? You can see this bridge. Another example, a shade, a roof, correct? You can see here different members are there, different things, connections, horizontal, vertical, at angle, correct? So these are different joints, different members. What are those things? I will tell you later on. Just I am giving you a sample. By this you will get an idea what is truss. These are the live examples. Now you can see here Prakasham barrage. There is a railway line before it, correct? In between Prakasham barrage and Krishna barrage, correct? So here you can see a small dot 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 punch punch punch, correct? These are nothing but joints, and this inclined one is nothing but member. Top side this is also known as member. This vertical, all these things are members. Where two members will join, this is known as joint. Just I am giving you a small flavor. This TV tower, all these things are nothing but example of trusses and frames. So what is truss? Truss is a structure made of slender bars that are joined together at their end by help of pins or by rivets and weld. You can say you have listened welded joint, riveted joint, correct? Pins. So you are joining different bars through pins or rivets or welds, correct? Now what is slender bar? Slender is nothing but length is long in comparison to width. Length will be very much long in comparison to width, then it is called as a slender bar. Okay. Now in right side you can see different bars are there, horizontal, vertical, inclined. They are meeting at one point. So this will give you a joint where they all meet together at point P. It is joint, and these are different bar members. Okay. Again, bridge is there, road is going, train is going, correct? Loads are acting on it. This arrow color in the top figure, this red color, violet color, the arrows are telling you loads. When train is moving, there will be load. When bus is moving, there will be load on bridge, correct? Now, how truss is working? It is having some supports and some loads, correct? Actually, it comes under structure. In structure there are two things, truss and frame. Left side truss, right side frame. What difference you can see here? Any difference? When you talk about truss, what is happening? Here A, B, C, D, E, F, G, what are those things? Where different lines, here these lines are nothing but members. These members are joining at this point. These points H, G, C, D, B, these are nothing but joints. So they are joints and they are members. We will go through all these things throughout this CO. Then what is this blue color at B, D, H, G? These are the loads acting on it. Then what is at A and E? These are supports. So they are supports and loads. Okay. Now these blue color things, where they are acting? They are acting either on member or at joint. Yes, they are acting at one point, that is joint, in B, in D, in H, in G. They are not acting throughout in BC or BD. They are acting at a point, that is joint, correct? This is truss. When you talk about frame, in frame the force will act throughout the member, from B to C, from C to D, throughout the member it will act, then it is a frame. So difference is there between truss and frame. Truss means only forces will act only on the joint. In frame, forces will act on throughout the member itself. Okay. Now different supports. Roller supports means a roller is there. Hinge support, for example, when you are opening a door in your homes, how it is opening, you are applying a force at some arm and it will open, where it will, the door is joined through the walls. How? At the end there are two joints, some joints are there, correct? Those are known as hinges. So different types of supports you can see here, examples, correct? These are daily day-to-day life examples. Applications you have seen already, bridges and all. Types of trusses, here different shapes you can see here. Members are arranged in different pattern, forming different types of trusses. Now zero force member. What is this zero force member? In the members forces are acting, in the joint forces are acting. For example, here load P, it is acting at joint P, B. What you will do? You will find forces in the member BC, BD, BE, BA, all these things. When you will resolve it, in CO1 we told you how to resolve forces, correct? You will resolve here x and y component, horizontal, vertical direction, find forces on different members BC, BD, BE, BA. Okay, AE, ED, everything. You will find there are some members there will not be any load. Those members are known as zero force members. Okay. Now these are how you can identify zero force members. I told you by resolving only. Very simple. Okay. Here this horizontal will not have any force, only vertical is having forces. So this horizontal will is nothing but zero force member. There are some assumptions for truss, you can see afterwards. Okay. Now nature of forces. The force acting on member is known as axial force. Why? Because it is acting throughout the axis of the body. So it is axial force. Okay. Nature of force means, now in above one you can see what is happening. There is one scale or rod and two persons are pulling, stretching from both sides. Force is acting opposite side, tension. So this is known as tension force, tensile force. In the downside what is happening? You are pressing, for example balloon, you press by both the hands, correct? Best example. You are pressing means you are compressing it, compressive force. Tensile force acting outside, compressive force acting inside. Tensile force means positive direction, compressive means negative direction. Now how you will analyze the truss? There are two methods, method of joint and method of section. This is method of joint. How, what you will do? As I told you, we will see condition of equilibrium, find summation of forces in x direction, y direction, find summation of moment, and we will make all the things equal to 0 to find the forces in the members. For example, this is one problem. There are 4 members AB, AC, BC. There are 2 supports at point B and point C. Point C there is roller, point B there is a hinge. How I am saying it is roller in point C? You can see here some small balls are there, correct? It is nothing but roller. Bearings you can take example, and point A, external load of 350 Newton is acting, correct? So this I have to solve. I have to find forces in AB, AC and BC. How? So by applying, first of all you will remove body supports, you will make free body diagram, means remove the forces, apply the external forces. Different types of supports will give different types of forces. Some will give only one direction, some will give in both direction. Hinge support will give you forces in x and y both, whereas roller will give only a normal direction force. Here normal direction is vertical. So, we will remove support, we will apply forces only, and external force which is acting at point A. Now, what we will do? We will apply momentum, we will find summation Fy, summation Fx equal to 0, and we will find some forces. After that, we will take one joint. First, we have taken joint B. When we took joint B, what will happen? Rbx is acting, Rby is acting, means resistance reaction force at point B in x direction and in y direction. Next, force in member AB S1, force in member BC S3. Okay. Before that, they are acting at angle. How much is angle? For that, we will apply some mathematics, Pythagoras theorem or whatever. Distance are given here, vertical and horizontal distance. Apply those things and get the angle. Here we are getting angle 36.86. We are assuming both the forces are acting in tensile direction, means outside. We are taking positive. This is our assumption. We will assume all are in positive direction, means acting outside from the away from the joint. Okay. Do summation of Fx0, summation of Fy0, get the values. When you get the values, you came to know S1 is coming -1. Assumption was it is positive, but after finding resolving we got it is negative, means it is compressive. In the same way, do for joint A, C, all these things and get all the forces and the natures. Nature means it is negative or positive, tensile or compressive. This is the joint of method. Now, method of section, that was method of joint, now method of section. In this, what we will do? We will divide into sections. You can see here top diagram, a line NN is there. That line is dividing into two parts. We have to select section carefully. We have to reduce our time. In first method, what is happening? We have to take each and every joint. So, the process was very lengthy. To make it short, what we are doing? We are dividing to sections. This section we have to decide, and we have to divide carefully. Okay, it will come by practice. So, we have divided, then we have taken one section, either right or left, and then apply equilibrium condition. What is equilibrium condition? Summation of forces in x direction equals to 0, summation of forces in y direction equals to 0, and summation of momentum equals to 0. Okay. This is one example. Now, same thing, remove supports, okay, apply the reaction, then divide into section. Okay, this is section line, dotted line. Take any section whichever you want, apply condition of equilibrium, summation of forces x direction 0, y direction 0, summation of moment 0. Apply all these three equilibriums and then you will get the answer. That is about trusses. Over. Now coming to special forces, this is one example, Bahubali, seen. Correct? Everyone has seen. What is happening? The ropes are coming from different directions and it is from different planes, different directions from different planes. This is example of non-coplanar forces, and this is special force because here all directions are coming in picture. Another example like this, there are many examples. Chimney, in industry you can see the chimney power plants from where smoke is coming. This chimney is supported with the help of ropes from different directions. A camera stand, okay, you can see a tripod. Tripod means 3 stands on different angles, different planes, correct? Non-coplanar, but they all are meeting at one point. So, no coplanar and concurrent. Concurrent means meeting at one point, but in different planes. This is one example of special forces. Another example, person carrying this cart, you need 4 persons to handle from 4 places, correct? And to whom they are lifting, that person is having some weight. So, weight of all forces on 4 different corners and weight of a person to whom they are carrying, correct? All are parallel, but in different planes. So, example of non-coplanar and parallel forces. There are some day-to-day life problems. How to solve such problems? So, force is nothing but vector, correct? So, there is x and y and z represented by I, j and k. Okay, I, j, k will give you unit vector, x, y, z is direction. So, f x I, f I, j, f z, k. This will give you total force. You are dividing into different components. Okay. Now, how to find f x, f I, f z? With the help of angles. Okay. Next, d. D is the distance. How you will find distance? Again, like force, divide distance also. Why I am doing all these things? Force, distance, because I have to find moment. Moment is nothing but force and distance. First, what we have done? We have divided force into x, y, z direction, and we find complete final resultant force. The same way, we find dx, dy, dz. Distance nothing but difference between 2 points in x, y and z direction. Then this downside will give you resultant distance or displacement, you can say. Okay, this is the formula. Note down this, these are the important formulas. So, find f and d. These are some particular conditions which you face in day to day life, and for those what are things required? Only forces summation is required, sum of force of two directions and one moment, or only summation of forces only, or moment force combination. Many combinations are here. You can go through these things. The slides will be given to you, and then at last for equilibrium what will happen? Total sum of force should come 0, then only the things will be equilibrium. For example, chimney is straight vertical. How? Forces are acting on it from all directions are 0, then only it is vertical. Otherwise, it will bend, collapse. Okay, these things already you have seen, and these are some real time problems. A weight from different hooks, cranes are there. You can see when you are constructing a building, a huge tall buildings, cranes will be there holding bars from one place to another place. Okay, a hot gas balloon. Okay, in middle a weight is there. You weight, you can take example, you are, so at in starting it is tied in the ground. How? You tie with the help of some rope, then you will cut the rope, then it will fly up, correct? So, these are some examples. So, you will go through all these things. These are very interesting things, my dear friends. So, you will enjoy the class of engineering mechanics. Thank you. This is about CO2. That's all. We will meet in the next class.